All right, so we are using synthetic division today. Hopefully it rings some bells. All right, so with synthetic division is when you're dividing a polynomial by a linear. So if I have x minus 5, that's a linear, right? Because it's a first degree polynomial. The first thing you do is you find the 0. And what would the 0 be here? 5. After you find the 0, you then are going to write out the coefficients of the polynomial. So my coefficients are 1, -2, -8, and -35. Agreed? All right. After you do that, then that's where the fun begins. You bring down the first coefficient. We multiply diagonally. So 5 times 1 is 5. You put the product here, and then we add vertically. So -2 plus 5 is 3. Multiply diagonally. 5 times 3 is 15. Add vertically. -8 and 15 make 7. Multiply diagonally. 35. Put the product. Add vertically, and it gets 0. So what that means is when we end with 0, that means that x minus 5 is a factor of that polynomial. And because you divided out 1x, you're now going to put your variables back into place, but minus 1x. So it becomes 1x squared plus 3x plus 7. And then you keep going from there if you can continue to factor. Okay, and that's what we're going to be doing. Got it? All right, let's dive in. So the first thing you have to do is figure out what 0 words. So we talked about yesterday how to find your potential zeros. That's our P over our Q. Does that ring a bell? Okay, so our P represented the factors of our constant, and Q represented the factors of our coefficient, leading coefficient. So P over Q, we get the factors of 4 are plus or minus 1, 2, and 4. The factors of 3 are plus or minus what? Factors of 3 are 1 and 3, Ms. Jones. Good job. I knew you knew it. All right, so that means that our potential zeros are, we have plus or minus 1, plus or minus 2, plus or minus 4. We have plus or minus, where are we at? 1, now we're on the 3. So 1 divided by 3 is plus or minus 1/3. Plus or minus 2/3. And plus or minus 4/3. All right, if we use, what's that guy's name? Descartes' rule. When we look here, how many sign changes are there? We went from positive to negative and negative to positive. So there's 2 sign changes, right? So either I have 2 positive numbers or no positive numbers. Or I have 2 negatives or no negatives. So how do we want to start? You just got to literally choose a number that you think will get you to 0. Want to start easy with 1? We can start easy with 1. So I'm going to put 1 in the box, write out my coefficients, 3, -5, -4, and 4. Start it up. So you bring down the 3 and we diagonally multiply. What's 1 times 3? What's -5 plus 3? What's 1 times -2? What's -4 minus 2? What's 1 times -6? And what's 4 minus 6? Is this a 0? No. So does that tell me about 1? It is not a factor. Does that make sense? So then what else should we try? Said -1. All right. We'll try -1. So we're going to bring down 3. -1 times 3 is? -5 and -3 is? -8. -1 and -8 is? -4 and 8 is? -1 and 4 is? And what do we get? 0. So that means that this was a factor. Does that make sense? So because it's a factor, that means that x plus 1 times 3x squared minus 8x plus 4 thus far is a factor. Then at this point now, you either can repeat it again for 3x squared, or you could just use your quadratic rules. So you have the x, the box, the quadratic formula, however you want to choose to break this one down. If I have 3x squared, if you remember the x box, it's saying what multiplies to give me 12, but adds to give me -8. So what two numbers multiply to give me 12, but add to give me -8? -6 and -2. That's not a 2. So that means in the box, it's always your first term, 3x squared, your last term, and then your magic numbers, -6x and -2x. What do you do on the outside to factor? You just ask yourself, what's the greatest common factor? What is the greatest common factor? Why did I write this so tiny? Between these two, x. What's the greatest common factor between these two? -2. What's the greatest common factor between these two? 3x. What's the greatest common factor between these two? -2. So your full factor is x plus 1 times x minus 2 times 3x minus 2. And if you look right here, every last one of these zeros was an option, right? We could have tested -1, we could have tested +2, and we could have tested +2/3, and they would have all worked.
Would it be -2?
It's the, yeah, if you set this equal to 0, +2.
What's the leading coefficient? Which is 3?
Mm-hmm.
Oh, yeah.
Yep, it's just 3. And so that would be your fully factored form. And from the factor form, you can now tell me, you can also say the 0. So where are my intercepts? My intercepts are at -1, 0, +2, 0, and at +2/3, 0. Mhm. What did I get the what from, babe? When you are doing the X box, remember you are multiplying your A term and your C. And so 3 times 4 is 12. And then your B is what you add up to. So it multiplies to give me A times C, but adds to give me -8. Yes. So, oh, you weren't here yesterday. So these are our potentials. So your potential zeros come from the factors of your constant divided by the factors of your leading coefficient. So our constant is 4, and the factors of 4 are 1, 2, and 4, right? And they're opposites. The factors of 3, our leading coefficient, are 1 and 3, and plus their plus or minus of them. Yes, that's what factors are. And then you divide. So 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. Then you'll do the 3. 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. 4 divided by 3 is 4/3. You're welcome. And so like Descartes said, we would either have 2 positive zeros. Do we have 2 positive zeros? All right, questions, comments, concerns?
Could you explain
the change in signs? So basically Descartes is saying that if you're examining from one term to the next, if they're changing in signs, so I went from being a positive to negative, that's one change. That stayed. And then I went from a negative to a positive, that's a second change. Because there are two changes, that means that there more than likely I would have two positive zeros. And then the other one would have to be negative. So it just kind of helps you narrow down your potentials. Mhm. Yeah. And then the other one, then obviously the opposite. And in this case, we had two positive. Question. We're going to do another one. Are we ready? So let's try it again. So again, we're going to first find our potentials. Our potentials are based off of P over Q. P, factors of 2. And the factors of 2 are 1 and 2, right? Q, the factors of 2 again, 1 and 2. So therefore, my potentials are plus or minus 1. And plus or minus 2. And plus or minus 1 half.
There's two is just one.
Exactly. No point of writing it twice, right? Do you understand why these are our potentials? Okay. Now that we know our potentials, then we're going to start. So if to get an idea, notice I have how many sign changes? I went from positive to negative once, twice. Okay. 2 times. So they're not going to all be negative and they're not going to all be positive. There's at least 2 of each. Well, there's 2 of each. All right. Where do we want to start? We're going to start with 1. Always the easy number to start with, right? Write out my coefficients. 2, negative 1, negative 5, 2, and 2. I'm going to bring down the 2. 1 times 2 is? Negative 1 and 2 is? 1 times 1 is? Negative 5 and 1 is? 1 times negative 4? 2 and negative 4 is? 1 and negative 2 is? And this makes 0. So that tells me that this is a factor. Yay. So we know that x minus 1 is one of our factors. Check. Okay. Now, you can do it again. And the reason why I say you can do it again is because is this a quadratic? No, this is a cubic. And we don't have any factoring rules for cubic, right? So we're going to do it again. Or you can do the cubic and factor by grouping. What do you want to do? Do you want to try synthetic again or factor by grouping? Yeah. So we choose factoring by grouping. This becomes 2x cubed plus 1x squared minus 4x minus 2. Remember, it was a 4th root, but when you divide, you've taken out one of the x's, right? So that's why we're x cubed. So factoring by grouping means I'm going to group the first 2 terms together and the last 2 terms together. The GCF here is x squared. The GCF here is negative 2. You see that? So I factor out x squared and I'm left with 2x plus 1. I factor out negative 2. And I'm left with 2x plus 1. Now the GCF is 2x plus 1. And what am I left with? x squared minus 2. And that is factoring with. So fully factored, we have x minus 1 times 2x plus 1 times x squared minus 2. Huh? X squared minus 2 won't factor out very pretty.
Yeah, it's like the square root of 2.
Yeah. I mean, you can write it that way if you want to. You want to be a little fancy. X minus 1 times 2x plus 1 times x minus the square root of 2 times x plus the square root of 2.
It is gonna affect that.
You want it? We can. This is all I want from you right here. Okay. Well, just lets me know is that one of them is going to be imaginary. The square root, square root of minus 2. No, never mind. I lied. It's all real. It's positive, not a negative. Silly me. And then that would be it. So your real zeros are at 1, negative 1/2, positive square root of 2, negative square root of 2. Now, if you put it in the calculator, would it tell you the square root of 2 part? No, it would give you a decimal.
Yeah.
It would not tell you the actual value. So in terms of zeros, so it says find the real zeros. You're at 1, 0. You're at negative 1/2, 0. You're at positive square root of 2, 0, and you're at negative square root of 2, 0. And those are your real zeros.
Yep.
And there's 4 answers. And should I have 4 answers?
Yep.
If there's not a multiplicity, I should, right? And I do.
Just how did you simplify it to a cubic?
When we did the synthetic,
Yeah.
that went from being a 4th degree to being a cubic.
And then we divide.
When you divide, it decreases the degree.
And the number stays the same.
The numbers stay the same, but your degrees are decreased. If I was to take x squared minus 2
Oh, you said it equals to 0.
and set it equal to 0, what will I get? That's what they're called, zeros. Because you take the factor and set it equal to 0. All right, how are we feeling? Doable? Because that's what your polynomial showdown is about. Yeah? Okay. All right, solving polynomial equations. So when you're solving polynomial equations, it's just another way of telling you to factor. The only thing is different is how you write your answer. Instead of writing it in factored form or as intercepts, you write them as x equals blah, blah, blah. That's the only difference. Everything else is the same, okay? So what I'm going to challenge you to do is for you to start. I'm going to give, let's say it's 5 minutes fair. Yeah, I think that's fair. No, you're not getting a class period, silly boy. I'm going to say 5 minutes and see what you can get done in 5 minutes. So a polynomial function with real coefficients of odd degree has at least one real zero, okay? Every odd function has to have at least one real zero, okay? However, even functions do not, okay? The theorem for bounds, we're not gonna really do. We're just gonna talk about via calculator. So when you are on the calculator, you can find all the real zeros of a function by doing a couple things. The problem is if you have a problem such as the quadratic one we just did, the calculator is going to give you a decimal, but that's not going to be the right answer if I'm looking for the exact value, right?
Right.
So be mindful of that as you're like, oh, I'll just use the calculator. No, no, no. because it's not going to tell you if that's the square root of 5. It's not going to tell you if that's the square root of 7, you know? It's going to give you an approximate value. However, problems like this, where your coefficients are already in decimal form, all you can do at this point is provide estimations. So in the handy dandy calculadora, here it is. If I was to graph this, notice how it says 2 decimal places. Well, then I would switch my mode first from float to 2. Then I would go to y equals and put in my value 7.3 x squared minus 8 and 1/4 x to the 4 plus 5. See you tomorrow. Minus 4x squared minus 9x plus y. All right, then I hit graph. All right, so there's the funky graph, right? I can zoom in on it. So if I hit 2, I'm like, yeah, let me zoom in a little bit. Because I need to be able to see my. All right, so notice how when I zoomed in, I probably zoomed in too much. Let me zoom in. So fun playing with the calculator. Nope. So lets me know that my values are repeats. Yay. So notice here, I know it's a 6th degree polynomial. However, when I look at the 6th degree polynomial, I can only see graphically 2 of these things, right? So when I'm analyzing the graph, I need to look at how it's changing, how it trace. When I trace the graph, I can see the change in the signs. I can see, okay, this is still negative. Then it switches to a positive y. So I can trace. I can also then find my real zeros. So my real zeros, and notice the keyword here, it says, what did it want? Does it care about the imaginaries right now? No, it only wants the. So to find my real zeros, I'm going to go second, trace. You see where it says 0? Pretty straightforward. Okay. Where's my little guy at? Where's my spider? Oh, he's all the way in the negative. Something. All right, here's my spider. So when you're trying to find the zeros, you have to be negative, then positive, or positive, then negative. Does that make sense? There has to be a change in your y values in order for it to know that that's what you're seeking. So right now I'm in the negative y's. I switch to positive y's. It's like, you want me to guess? You want me to tell you? Yeah, I want you to tell me. It does a little thinky thing. And it says, your real zeros where? At -1. Okay, then I'm going to do the same thing again, but to the other side. So second, trace, 0. This time I'm going to go from a positive to a negative. So I need to go from positive to a negative. So I'm at positive y. I'm going to keep going until I become a negative y. Hit enter. Does a little thinky thing. And it says your other value is at approximately negative 0.12. So 1200s. So my real zeros are at -1, 0, and that would be my answer. And that's how you do it with technology. Questions about with technology?
So we switch to
The degrees? With the,
I don't know, not the degrees, but
oh,
from negative to positive, you just things where you were at.
yes, you just move the spider around. I mean, I don't think it's really called spider, but you move the spider, the cursor. It looks like a spider, right? Looks like a spider crawling on the screen. So I've been calling this a spider since 8th grade. He's gonna be a spider. All right, questions about technology. I saved it to the end because it goes fairly quickly, but how do we feel? Good? And then that's it. Do what?